So good morning everyone. So we are back in our topic today. So our topic today is distance formula. So first, what is distance formula? The distance formula in coordinate geometry or Euclidean geometry is used to find the distance between the 2 points in an xy plane. The distance of a point from the axis is called its x coordinate or abisca. The distance of the point from the x-axis is called its y coordinate or ordinate. The coordinates of a point on the x-axis are of the form of x 0 and the point of the y-axis are the form of 0y. To find the distance between any 2 points in a plane, we make the use of Pythagoras theorem. Here, this is an important topic for class 10 students. Let us discuss more here the formula and its derivation with examples. So, what is distance formula in maths? So, in maths, the distance formula is defined for coordinate geometry. Students should not be confused here about the formula for speed and distance. So, formula of speed and distance is different. Both are completely two different topics. When we speak about speed and distance, it is covered under real-life scenarios. When a person or a vehicle move at a speed to cover a distance, it is a particular interval of time. Then the speed is equal to the ratio of the distance covered and taken time. So, distance formula and speed are different. So, speed is the time that covered the speed of a truck, and the distance is the how far that the truck goes. So what is distance formula? So the distance formula is the formula which is used to find the distance between any 2 points. So it is different from speed. Okay. Only its coordinates are known to us. These coordinates could lie on x-axis or y-axis or both. Suppose there are 2 points, say P and Q, in an xy plane. The coordinates of a plane of a point P are x sub 1 and y sub 1, and of Q are x sub 2 and y sub 2. Then the formula to find the distance between 2 points PQ is given by, this is the example of, this is the illustration of PQ. This PQ equals square root of x sub 1 minus x sub 2, x sub 2 minus x sub 1 squared, plus y sub 2 minus y sub 1 squared, or the distance equals square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So this is the distance, this is example of distance formula. So first is example 1, find the distance between 2 points of A, let A 1 and 2 and B negative 2 and 2. So A is x sub 1 and x sub 1 and y sub 1, and B is x sub 2 and y sub 2. So to find the distance formula between A and B, by the we use the formula of distance. We use the distance formula. D equals square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So let's substitute the formula to A and B. So A and B distance, the distance A and B equals square root of negative 2 minus 1 squared plus 2 minus 2 squared. So A and B equals square root of negative 3 squared plus 0 squared. So we can say that A and B is square root of 9, but we simplify it, we have the equivalent of 3 units. So this is the second example of our problem. So example 2, show the point 1, 7, 4, 2, negative 1 and negative 1 and negative 4, 4 are the vertices of a square. So we are going to draw a square, but first we need to prove if the given coordinates is actually for the basis of a square. So this is the solution. So let P is coordinate, the coordinate of P is 1, 7, the coordinate of Q is 4, 2, R is negative 1 and negative 1, and S is negative 4, 4. This is the coordinates of our 4 points in an xy plane. So to prove PQRS is a square, we need to solve each problem, each coordinate. So to prove that points PQR and S form a square, we have to prove that PQ is equals to QR, that is equals to RS, and equals to PS. So to summarize it, PR is equal to QS. PR is equals to QS. This is the diagonals of a square. So now we are going to solve each distance PQ, QR, RS, and PS to form a square. So first we are going to substitute the given coordinates of each coordinate. So we use the distance formula, which is the distance is equals to square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So in the side PQ is equals to 4 minus 1 squared plus 2 minus 7 squared. That is equals to 3 squared plus negative 5 squared. So we solve the exponent. So we have the answer 9 plus 25, which is let's just add them or combine them. We got square root of 34. So we have our side PQ, and then we need to answer side QR. So side QR is equals to negative 1 minus 4 squared plus negative 1 minus 2 squared. With that equals to, we combine negative 1 and negative 4, we got negative 5. We combine negative 2 and negative 1 and negative 2, and negative 1 minus 2, we got negative 3. So the square root of negative 5 squared plus negative 3 squared. So again, what we did on side PQ, we need to solve the exponent or the squared. So we have 25 plus 9, square root of 25 plus 9, and then like what we did in the PQ, we add the number 25 plus 9, that is equals to square root of 34. So in the side RS, you have negative 4 plus 1 squared plus 4 plus 1. So you might be wondering why we got the addition. In the given coordinates, we see that so you might be wondering why we use addition on side RS. So why addition? So the distance formula comes from the Pythagorean theorem, just as what I mentioned. So when you calculate the distance between 2 points, you are really forming a right triangle. So one side is the horizontal change. So the horizontal change is the x sub 2 minus x sub 1, and the side of the vertical change is the y sub 2 minus y sub 1. These two form of the leg of a right triangle. The distance between 2 points is the hypotenuse. So we all know what is hypotenuse. So according to the Pythagorean theorem, hypotenuse squared is equals to horizontal distance squared plus vertical distance squared. So distance squared is equals to x squared plus y squared, or just simply taking the square root. Distance is equals to square root of x squared plus y squared. So we coming back to the example of RS, we know why the solution is an addition. So RS is equals to square root of negative 4 plus 1 squared plus 4 plus 1 squared equals to square root of negative 3 squared plus 5 squared. So with that, we answer the squared. We got answer the squared or the exponent. We got the 9 plus 25 equals to square root of 34. So sides SP. So same what we did on RS, but so again, so my mistake. So you might wondering why QS is equals to YSP is equals to 1 plus 4 squared plus 7 minus 4 squared. So as we can see, the given on the S coordinate, we got on the S coordinate we got negative 4, 4. So we simply substitute the variables. So on SP, 1 plus 4 squared plus 7 minus 4. So you might be wondering why plus 4. This plus 4 is actually negative 4. So 1 times negative negative times negative is positive. That's why it is 1 plus 4. So continuing, 1 plus 4 squared plus 7 minus 4 squared is equals to square root of 5 squared plus 3 squared. That is we answer the exponent, so square root of 25 plus 9, which is 34. Square root of 34. So as you can see, all the answer of sides is square root 34. Drawing the line, we can say that all drawing the line of this each distance, we can say that they are all equal sides, which is the definition of a square. So that is how you solve distance formula.